So the next section of work, we'll be looking at rates of reaction, how fast or slow reactions go. So by the end of the lesson, you should be able to explain what a reaction rate is and how to measure the rate of a reaction. So you can also have to be able to explain how reactions happen due to collisions between particles, and also explain how surface area, concentration, and temperature affect the reaction rate using collision theory. So usually there's always chemical reactions. I mean, there's once I told a chemistry joke, but there was no reaction. So the rate of reaction is the speed at which a chemical reaction occurs. Some reactions are quick and some are not so quick. So for example, the formation of the copper carbonate layer on the iron Statue of Liberty, not so fast, whereas say the reaction with hydrogen peroxide and enzymes, for example, involve reactions are quite quick. However, you can change the rate of reaction. It can be altered. So how do we measure how fast reactions are going? There are two common ways. The first way is to measure how fast a product is formed. And that's what the illustration here is an example of. It's an example of measuring through the syringe how much volume of gas is formed over a period of time. And the second way of doing it is by looking at a change in colour. Or you can measure how fast the reactants are being used up. So for example, in this the example with the gas syringe, if you have it over a balance, you can see how quickly the amount of, say, the solid is being used up in the reaction. Okay, so once you've got the information about how reactants are being used up and products are formed, you can do a rate of reaction graph where you plot the amount of product being formed or the amount of the reactant being used up against time. Okay, and you should see that the reaction usually begins rapidly, very high and steep gradient, and then slows down as time passes as the reactants begin to get used up. There's less chance of the reactants colliding to form products. And finally, it stops after a certain time and the graph levels out as one or possibly both the reactants have been used up. So in collision theory, for a reaction between two particles to occur, the particles must collide and the collision must be effective. So for effective collisions, when the particles collide with enough kinetic energy, the energy of movement, so they're moving fast enough, and the correct position or orientation to break the bonds between the particles, this allows new bonds to form. So collisions can occur and yet result in no reaction, because either there is insufficient energy for a reaction to occur, or the particles are in the incorrect direction or shape or orientation to allow collisions to be effective and for products to form from the reactants. So, how do these reactions occur? Reactions take place when particles collide with the right amount of energy. If there's not enough energy, there's no reaction. Okay, not enough energy, no reaction. If the particles are or molecules are in the incorrect orientation, that doesn't allow the reaction to occur. Again, there's no reaction. Only when there's enough energy and the correct orientation does the reaction occur and the reactants are transformed into products. Also, something to consider is activation energy. Activation energy is the minimum amount of energy needed for particles to react, and it is different for every and each reaction. This is one of the reasons why some reactions are fast and some reactions are slow. It requires a lot more activation energy for some reactions to begin than it does for other reactions. If particles collide with less energy than the activation energy, they don't react. They require enough energy to allow the particles to break their bonds to go from reactants into the products. So let's also consider the amount of collisions and rate. The more frequently effective collisions occur, the faster the rate of reaction. The faster reactants are transformed into products. Okay, So to change this rate of reaction, we can do several things. We can either change the concentration of reactants, so there's more probability or chance that reactants will collide with each other, and also with the correct energy and orientation. Change the temperature of the reaction, so you're giving energy to the reactants, so the activation energy is met, so reactions become effective, the collisions occur with the right amount of energy to allow conversion to product. You can change the surface area of the reactants, which means that there are more reactants available to react, or you can use a catalyst which lowers the activation energy and also places the particles in the correct orientation and allows the reactions to occur on the surface of the catalyst. So, just looking at that in more detail in terms of concentration, if you increase the concentration of a reactant, this increases the amount of particles in a certain volume. This increases the chance or frequency of collisions, and this increases the rate of reaction. So at a low concentration, there are fewer collisions. At higher concentrations, there are more collisions. Therefore, there's more chance of more effective collisions every second. In terms of surface area, if you increase the surface area of a reactant, this increases the number of particles available for the reaction to occur. This increases, again, the frequency of collisions. Very important to use the term frequency. And increases the rate of reaction. So there's more chance that you're going to get effective collisions and therefore effective reactions. And you've also got temperature. An increasing temperature of a reaction increases the amount of energy or kinetic energy, the energy of movement, in these particles. This means that the particles will collide more often and they'll also have more energy. So again, this is increasing the frequency of the effective collisions, which increases the rate of reaction. So in summary, I want you to draw the following table in your books and summarize why slow reactions occur and why fast reactions occur, and ways you can make reactions faster, and the understanding also the reasons behind why the things you change increase the rate of reaction.